Alright, there is a perpendicular bisector theorem that we're going to talk about. And what that means is this. And I'm just going to point it out as we read it. If a point is on a perpendicular bisector, so if this point is on a perpendicular bisector of a segment, then it is equal distance from the endpoints. For instance, this P right here, and I realize there's a proof. It's a little bit of an awkward proof based on reflections, and we can talk about that sometime, but this point right here, what we're saying is that this point is equal distance. In fact, these 2 points are equal distance from any point as long as we're on a perpendicular bisector. Alright, so let's use that. So specifically, right here, we see that these 2 segments are equal length and that it's perpendicular to this line that J lies on. So what that's saying is that L and K here are also equal distance to J. Notice I used 2 tick marks instead of 1 because we had 1 up here. So let's come down here and do this. Alright, so this says ED is 16, right? It says DA right here is 20, and then it says find DC. Well, look, there's what we need. We need that perpendicular marking. We need these bisectors, so we know these 2 are the same. That makes DC the same as DA, so DC is equal to 20 centimeters. Now it says suppose EC is 15, right? And BA is 25. Find BC. Well, we could realize that this is also perpendicular, so these 2 are the same. We actually didn't even need EC, we just needed to know that these were the same. BC is also 25. Alright, so if the point is equal distance from the endpoint of a segment, then it lies on the perpendicular bisector. So notice we're just doing the opposite. Here's what we're saying. We're saying that if we have a point out here and that it is equal distance here and here, so now we know it's a perpendicular bisector. So it's the same theorem in reverse. So look, closing task. AD is 10, BD is 6. Find the length of AC. Well, that's a wonderful question. Notice this, so notice something here. These 2 are the same. Alright, so this is also 10. That means that this is a perpendicular bisector. Alright, this point is equal distance from both endpoints on a segment, making this a perpendicular bisector. This is the converse of the perpendicular bisector theorem, and all we have to do is find out one of these. Well, it just so happens we realize that Pythag created a squared plus b squared equals c squared. Alright, so we could say, let's plug in these legs, x squared plus 6 squared. X squared plus 6 squared equals 10 squared, which gives me x squared plus 36 equals 100. I subtract 36, x squared equals 64, and that's going to give me a positive or negative 8, which I must also put over here. Right? Both of these are 8. So it's saying AC. If both those are 8, AC is 16 all the way across. Alright. So we're going to stop there, and we're going to come back and do proving theorems about right angles.